Good morning, IB. We're going to take a look at 6K, where we're going to continue to look at some more trig identities. And the three we're going to talk about today are biggies. These three are pretty big ones. These are known as the Pythagorean identities. Trig identities. I should have put Pythagorean trigonometric identities in here. And they are as follows. The sine squared of an angle plus the cosine squared of an angle always equals 1. I'm going to do a quick note about sine squared here in a moment. I'm not sure how much we've talked about this, but let me give you the other identities first. The next one is 1 plus the tangent squared of any angle is always equal to the secant squared of any angle. And then the last one is that the cotangent squared of any angle plus 1 is equal to the cosecant squared of any angle. And remember, they write cosec. So just a quick note about sine squared of an angle. Sine squared of an angle is really the sine of an angle squared. Okay, it's not the sine of an angle squared. It's the sine of an angle squared. So very important differentiation here. All right, so before we actually start using this, let's just prove one of these. And if I was in class, I would say, which one do you want to do? And we could pick one. It really doesn't matter. Once you've seen the proof to one of them, you can figure out the other ones. Let's do sine squared plus sine squared equals 1. Let's prove it. Prove that the sine squared of an angle plus the cosine squared of an angle is always 1. All right. Well, if I think about what does sine squared of an angle mean? Well, if I have an angle, I have the opposite side, the adjacent side, and the hypotenuse. The sine is opposite over hypotenuse. So instead of sine squared, I'm going to put opposite over hypotenuse squared. Plus, the cosine is adjacent over hypotenuse. Adjacent over hypotenuse squared. I'm trying to prove that that equals 1. All right, so I'm going to get opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. Common denominator, combine them. Opposite squared plus adjacent squared over hypotenuse squared. But wait a minute, opposite and adjacent squared. We know Pythagorean theorem tells us that the opposite squared plus the adjacent squared is equal to the hypotenuse squared. Pythagorean theorem. So substitute that in here, and I get hypotenuse squared over hypotenuse squared, which sure enough equals 1. Anything over itself is 1. So there's a quick proof. Now let's take a look at a couple of applications here. So what I'd like to do is we'll start with one that's relatively simple here, very similar to things we've seen previously. Suppose I tell you that the sine of any angle of certain angle is 3/5, and that theta is an acute angle. Well, why is that important? The fact that it's acute means it has to be in the first quadrant. And I want to find the cosine. Well, if it's in the first quadrant, cosine in the first quadrant is going to be positive. My final answer is going to be positive here. Now, in previous lessons, we did this by making our triangle, putting theta there, opposite over hypotenuse, use Pythagorean theorem to find the missing side, and then write the cosine of it. But I want to do it using my identities. So I know that sine squared of any angle plus cosine squared of any angle equals 1. The sine squared is 3/5. So 3/5 squared plus cosine squared equals 1. I'm going to subtract 3/5 from both sides, and I get the cosine squared of theta equals 1 minus, let's see, what is this really? 3/5 squared is going to be 9/25. So the cosine squared equals 1 minus 9/25. 25 over 25 minus 9 over 25 is 16 over 25. Take the square root of both sides, and the cosine equals 4/5. There's my answer. And of course, if we had done the triangle here, we would have seen this is a 3, 4, 5 triangle. And this would probably, the way we've done it before would probably be a lot quicker and easier. But as these things get harder, we'll have to deal with just these identities. Let me give you an example. Let's take a look at some harder problems now. So in the next one, I'm going to tell you that that c is equal to the cosine of theta, and I want you to simplify the square root of 1 minus c squared over c. All right, well, substituting in, I'm going to get the square root of 1 minus cosine squared over cosine. The c is cosine theta. I substitute in here and here. 1 minus cosine squared. That should look familiar. That should kind of jump out at us here. We know that sine squared plus cosine squared equals 1. So sine squared is equal to 1 minus cosine squared, Pythagorean identity. So I'm going to take the sine squared and substitute it in there. And then I get the square root of sine squared over cosine. What's the square root of sine squared? Sine over cosine. And what is sine over cosine? Tangent. So this simplifies to tangent. Let's take a look at another one, maybe a little bit more difficult here. Suppose I tell you, suppose I want to simplify y times the square root of b squared plus y, given that y is equal to b cotangent of theta. All right, so knowing this, I'm going to substitute in. So I want to simplify the expression y times b squared plus y squared. Whoops, I forgot the square. Y squared equals b squared plus y squared, given the fact that y is b times the cotangent of theta. All right, so now substitute in. I'm going to get b times the cotangent of theta times the square root of b squared plus b cotangent theta squared. I'm going to write it like that for a moment. Now I'm going to substitute, or not substitute, rather, b squared plus b squared cotangent squared. And I'm going to factor out the b squared. B times the cotangent of theta times the square root of b squared times 1 plus cotangent squared. And 1 plus cotangent squared, we know that that is cosecant. That's going to be cosecant squared. So I'm going to get b times cotangent theta times the square root of b squared cosecant squared, substituting it from my identity. Take the square root, and I get b times the cotangent of theta times b times the cosecant of theta. And I want to simplify this. Well, let's see what's going to happen here. I get b, cotangent is really 1 over tangent, which is really cosine over sine. Cosine over sine times b, cosecant is really 1 over sine. So I'm going to get b squared cosine over sine squared. I could just leave it like this as the b squared times cotangent cosecant or I could rewrite it like this. Cosine over sine is the cotangent, 1 over sine. And it really depends on what I'm going to be doing. I could have left it as b squared times cotangent theta times cosecant theta. I could have used this answer in the future, or I could have used that answer in the future, just depending on what I'm going to be doing or where I'm going to be going with it. All right, let's take a look at another one. So let's take a look at solving. Let's solve something like 3 minus 3 cosine theta equals 2 sine squared theta. If I put this in standard form, I'm going to subtract the 3 and add that. I'm going to get 0 equals 2 sine squared theta plus 3 cosine theta minus 3. Now notice I've got sines and cosines going on. I want to simplify it and rewrite it just in terms of one trig. So sine squared I know is 1 minus cosine squared. 2 times 1 minus cosine squared plus 3 cosine minus 3. Distribute the 2. 2 minus 2 cosine squared theta plus 3 cosine theta minus 3. Simplify, write it in descending order. Let me try a different red pen. That one's getting a little thick. 0 equals negative 2 cosine squared theta plus 3 cosine theta minus 1. I want my lead coefficient to be positive, so I'm just going to multiply everything by negative here. And I get 2 cosine squared theta minus 3 cosine theta minus plus 1. Now what? Well, do you see the quadratic in here? Is it factorable? 2 times 1 is 2. Can I think of two things that multiply together 2 and add up to give me negative 3? Yes, I can split the middle term here and factor it. So I'm going to get 0 equals 2 cosine squared theta. And let's see, 2 times 1 is 2. I want a positive 2. So plus 3, I want two things that multiply together to give me a positive 2 and add up to give me negative 3. So minus cosine theta minus 2 cosine theta plus 1. Let's see, will that work? 2 times 1 is 2. Negative 2, negative 1. That should just be negative 1 cosine. Negative 1 and negative 2 give me negative 3. I'm splitting the middle term here. Group, and I get 0 equals 2 cosine squared theta plus cosine theta plus negative 2 cosine theta plus 1. Out of this group I can pull out a cosine, and I get 0 equals cosine theta times 2 cosine theta plus 1. Here I can pull out a negative 2 cosine theta. Well, that should be a negative there, shouldn't it? That should be a negative. That should be a negative, 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 negative 1. And then pull this out, and I get 0 equals 2 cosine theta minus 1 times cosine theta minus 1. Set each factor equal to 0 and solve. 2 cosine theta minus 1 equals 0. 2 cosine theta equals 1. Cosine theta equals 1/2. Cosine theta minus 1 equals 0. Cosine theta equals 1. And then I have to think to myself, well, where on my unit circle does cosine equal 1/2 and cosine equal 1? Now for here, cosine equals 1. Think about the unit circle for a moment. Let's draw up a unit circle here to help us out. If you've got your unit circle, you might want to have that to help us solve this. Cosine is the x value. Where is the x value equal to 1? Right there. So that's going to be 0 pi. Anywhere else, well, I could do the whole n pi thing, but every 2 pi after that. How about 1/2? Where is cosine equal to 1/2? In other words, adjacent, cosine is adjacent over hypotenuse. So what angle is that right there? That's going to be a, what is that, 60-degree angle in radians. That would be pi over 3. But wait a minute, cosine is also positive down here. So what angle would it be down here? 5 pi over 3? So I get 2 solutions there. All right. Tough one. Lots of stuff going on in that one. So now I want you to go ahead and do assignment 6K. So we're kind of plowing through these things a couple a day, do at least one a day. 6K is on page 403. I want to do the problems 1 through 4, all of them. Problem 1 is simplifying. Number 2 is also simplifying, substituting in, using our new identities. Number 3 is solving. Got to know your unit circle. Have that unit circle handy, or draw a unit circle to help you solve them. And number 4 is just simplifying some expressions by substituting in, by factoring, by rewriting them into single terms. Those can be, some of those ones can be very frustrating. Some of those simplifying. Sometimes you can kind of spin out of control on them and get very confusing and very frustrating. And don't be afraid, I think I've said this before, don't be afraid that if you kind of spin out of control on simplifying some sort of trigonometric expression, to just kind of throw it all away, scrunch it all up, cross it all off, and start again. And we're going to be getting into some of those coming up pretty soon here with double angle and half angle and some other weird stuff going on. And it's really easy to spin out of control on these things. All right, guys, good luck, and I will talk to you again soon. Bye.